Gonna finish up lesson 31. I actually wanted to work through the ending of 12b so that you can see what's actually happening here mathematically. Now, I want to take this thing and write it as a fraction. I can't do it in my calculator. My calculator won't let me. So what I'm going to do here is I'm going to multiply the top and bottom by 1,000. Now, you saw that in the last video, okay? Unless you missed it, which is okay, because that's what I'm going to do here. So, I multiplied top and bottom by 1,000. Why did I do this? I did this so that this 0.045 multiplied by 1,000 is actually just going to be a value of 45. Okay. Then I'm going to take this 1,000 and distribute it on the bottom here. Okay. When I distribute on the bottom, I'm going to have 1,000 minus, and then 1,000 divided by 100 is really just going to be 10. Okay. Plus that 0.3. Now, 45 over what this really is 990. This is plus 3 over 10. It's 3/10, so it's 3/10. Okay. Then what I did was I typed this into my calculator, and I hit the math enter button to look at the fraction, okay, not the actual decimal. And I saw 19 over 55. Now, in the last video, I ended very, very abruptly with, you can do probably most of this work in a calculator. However, I do not want to see you doing this in the calculator. You need to show me the steps. You need to do it by hand. Okay, I need to see that formula S sub infinity, or just simply S equals to the first term divided by 1 minus R. Okay, you have to do this by hand. Now, I'm done with technically the lesson, but I wanted you to see one last thing. Okay, I wanted you to see why. Why is it that when R is less than 1, and I do this an infinite number of times, do I get an actual number? Does it approach to an actual number? Well, let's talk about a situation. I know I've talked with some of you about this situation before. Okay, let's go ahead and draw a nice little picture here, I suppose, from here to here. Okay, this is 0. Let's call this 1. Okay, let's call this a number line. Let's say that I'm a human being that can take a step from here to here. Okay, but physically it's impossible for me to actually do that. Okay, so what I'm going to do is I'm just going to take half that distance. So I'm going to cut that distance in half. There's 1/2. Okay, so from 0 to 1/2, I'm taking that step right there. Next, all I can do now is take another half step distance. Now, I don't mean half step of 1/2 distance. I mean legitimately half of the distance that's left. Let's assume that I can only take another half distance step. So from 1/2 to 1/4. Okay? Let's continue this notion of all I can do is take a half step of the distance that's there. Now I'm going to have 1/8 from here to here. And then a 1/16, cutting that in half. And then a 1 over 32, cutting that in half. Now, it's gotten to a point where I can't draw that distance. I mean, I can try. There's the next one, okay? But notice I'm getting closer and closer to the value from 0 to 1 every single time. The question is, will I ever reach 1? And in theory, no. If I take the step, half the distance, 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 half the distance. If I continue to half the distance, and if I zoom in on this piece right here, you will see that I'll just keep cutting the distance in half, keep zooming in. Cut the distance in half, keep zooming in. Cut the distance in half, keep zooming in. And I won't ever get to 1. Okay? I'll continue to approach 1. The idea of S equals to A sub 1, 1 minus R. The idea of this thing right here. If I continue to cut the distance in half every single time, okay, if my R value is less than 1, it means that I'm cutting the distance by a certain value. This R happens to be equal to 1/2. Where did I start? Okay, well technically I would have had to start it at 1/2, but we're not going to talk about that, okay? What we're going to really talk about here is the fact that as I continue to add up all these terms, 1/2, plus 1/4, plus 1/8, plus 1/16, plus 1/32, 1/2, plus 1/4, plus 1/8, plus 1/16, plus and so on and so forth. I started at 1/2. I have 1/2 divided by 1 minus 1/2. That's 1/2 divided by 1/2, which is 1. The idea of this series that I'm looking at right here in terms of this visual representation is the concept that as long as my fraction value, my R value, the change value is less than 1, I will always be approaching a number. As opposed to if I were to go from 0 to 1 and take a step anything larger than 1. So let's just say I take a step that's, I'm going to go ahead and way over here on the other side of this page, write a value of 7. I'm going to take a step that is 1.5 times that distance. So from right here to here is 1 1/2. Now I'm going to take another step that's 1 1/2 of that. Okay, so it's actually going to be larger than that. So 1 of that is 1 1/2. Half of that is 0.75. So that means I'm going to end up at 2 at the next value. And then I'm going to continue that, and this distance is going to actually continue to get larger. Whereas this distance will always get smaller if my R value is less than 1. Again, I wanted you to see that there's actually a good joke that mathematicians have about this. If you want to hear it, ask me in class. Okay. Otherwise, that completes all of our lessons for pre-calculus. There's supposed to be a lesson 32, okay, but we're actually not going to do that this year. So you made it through. All you got to do now is make sure you can pass the tests, okay?